All right, so this is lesson number 5 of this trigonometric functions unit. So we're looking at now combinations of transformations after looking at stretches and translations separately in the previous lesson. So when we have equations that contain multiple transformations, you can do everything at once if you're feeling very comfortable with the transformations. But if it helps to break it down a little bit, I would suggest we're going to look at just the stretches, so horizontal and vertical stretches first. So those are the A and D coefficients in our standard equation. So here's our general sine and cosine equations. So first we're looking at the A and D's, the multiplications either outside the function or inside the function directly at x. And on those 5 key coordinates. Remember in the previous lessons we've talked about when we're graphing sine and cosine, we want the 2 points where, or the 3 points where it's crossing the axis of symmetry, and then one maximum and one minimum. So that gives us that one full cycle. So those points, if we're just looking at stretches, our x is affected by the d, and it's always multiplied by the inverse or divided by d, all of our x values, and our y values all get multiplied by our a value. And after that, we can shift things appropriately after. Our whole shape is just going to change by whatever our h and our c values are. If you would like to combine everything at once, this isn't shown in this lesson, but you are definitely able to do this. So all at once, our x values are still divided by d, and then our horizontal shift, they get subtracted by h, should not be a bracket there, and our y values, they get stretched by a factor of a, and then they get c added to them. This works for any function. So right back into parabolas, back in grade 10, your exponential functions, your logarithmic functions that you've translated or transformed, and now trig functions as well. This always works. So if you're comfortable doing it all at once, you can just change all your points like that. In this first example that we'll look at, we're going to sketch one cycle of the function y equals 3 sine of 2x minus 1. So we can see we have an a value of 3. We're going to have a vertical stretch by a factor of 3. We have a d value of 2. So we're going to have a horizontal compression by 1 over 2. And we have a c value of negative 1. We're shifting down 1. So our amplitude and period, which is two of the things we're most concerned about for these periodic functions. Our amplitude, remember, was affected by vertical stretches and compressions. So if we're stretching by 3, our standard amplitude is going to get multiplied by 3, so we get 3 instead of 1. And our period, we remember, is always 2 pi divided by whatever our d coefficient is. So in this case, it's 2. So 2 pi divided by 2. So that means our period is going to just equal pi. 2 pi divided by 2 is pi. So it's going to take only pi radians to complete one cycle. Our standard sine of x function, because we're looking at transformed sine function. Our standard sine function, we start off at the origin. So our x and y values, we're starting off at 0, 0. We increase a quarter of the way to our full period, so pi over 2. We're at our maximum, so pi over 2, 1. Then we go back to our axis symmetry, pi 0. 3/4 of the way, we're at our minimum, 3 pi over 2, -1. And then finally, one full cycle, 2 pi, we're back at the axis symmetry. So 2 pi, we are at 0. So that gives us hopefully this what is familiar, this sine shape. Now our transformed function, if I can fit this all in here, 3 sine of 2x minus 1. We're going to break this up, so we're only going to look at our stretches. Again, you can do this all at once. That's completely okay. But I'm going to do this for people who maybe aren't quite that comfortable yet. So horizontally, we have a horizontal compression by 1/2, because remember, horizontal is always the opposite of what we expect. So it's going to be x divided by 2. I might write that a little bigger because I know this camera is not the best. And our vertical stretch by 3 is going to multiply all of our y values by 3. So we're going to take all of our x values and divide them by 2. So we have 0, pi over 4, pi over 2, 3 pi over 4, and pi. And our y values, we're multiplying all of them by 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 0 is 0. 3 times -1 is -3. And back to 0. So that's just taking into account our stretches, our expansions, and our compressions. And now we're moving all of these values. I should not include our original one, but all these 5 key points, we have to remember that these are all going to get shifted down 1. So our point 0, 0, we have to remember to shift that down 1. Pi over 4, so halfway, be here. Pi over 4, 3. Let's put a 3 on there. We need to shift that down by 1. So we're going to get pi over 4, 2. Pi over 2, 0. Shift that down by 1. 3 pi over 4. And -3. Need to shift that down by 1. So I should expand my scale here. And these are all going down 1. Finally, pi 0, shift down by 1. Will be here. So here is one complete cycle of our transformed function. As we can see, this axis of symmetry is now the very middle of our minimum and maximum values. We're at -1. That's coming from this shift down we had. So our key features, we already mentioned, we have an amplitude of 3 from our maximum to our axis of symmetry, or from our minimum to our axis of symmetry. That is 3 units. Our period is pi. from the time it takes to complete one full cycle, we've gone pi units in our x direction. Equation of the axis symmetry. So that very middle point where we get all the most key points. Equation of the axis is y equals 1. Phase shift. So phase shift, again, this is from the last lesson. Phase shift is how much we're shifting left and right. We had no horizontal translation, so we have no phase shift. Domain, these ones aren't necessarily on the sheet, but still good to refresh. Our domain can be all real numbers. Our range has to be between -4, our minimum, and our maximum of 2. So our minimum is always equation of the axis minus the amplitude. Sorry, this should be y equals -1. So -1 minus 3 gives us that -4. -1 plus 3 plus our amplitude. So the equation of the axis plus the amplitude, that'll always give us our maximum. So our next example, we're going to look at y equals -3 sine of 3x plus pi plus 1. So the first thing before we can even start to talk about transformations here, we always need our inside term to be factored. So we can rewrite this equation, and we're going to factor out a 3 inside the brackets. So if we pull a 3 from 3x, we just get left with x. If we pull a 3 from pi, we get left with pi over 3. So always remember that if we have a coefficient of d that's not 1, we need to make sure that's factored if we have a phase shift. So now we can start to look at our transformations. Our a value is -3. So that's telling us that we have a vertical stretch by a factor of 3 and a reflection over the x-axis, a vertical reflection. We have a d value of 3, so that would be a horizontal compression by 1 over 3. We're going left by pi over 3 because we have a positive pi over 3 being added to our x. And the plus 1 at the end is telling us that we're shifting up by 1. So we'll look at our parent function, our sine of x. So we're going to have the same 5 key points we had before. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. So we'll put those on our graph. And that is our function y equals sine of x. Now our transformed function, our y equals -3 sine of 3x plus pi over 3 plus 1. All of our y values, all of our x values are going to get divided by 3, and all of our y values are going to get multiplied by -3. So it's not going to affect our original point at the origin, but pi over 2 divided by 3 gives us pi over 6. 1 times negative 3 is negative 3. Pi divided by 3 is pi over 3. 0 times anything is still 0. 3 pi over 2 divided by 3 is going to be pi over 2. The 3 is going to cancel out. Negative 1 times negative 3 is positive 3. And then 2 pi over 3, 0. So that is our stretches and our compressions, both vertical and horizontal. And we need to remember we are shifting left by pi over 3 and up by 1. So on this scale, our pi is 6 of these units across. So pi over 3, we need to remember to shift everything 2 units to the left. So our point 0, 0, we shift 2 units to the left and up by 1. Pi over 6, negative 3, we need to shift 2 units to the left and up by 1. Pi over 3, 0, we're going to go 2 units to the left and up by 1. Pi over 2, 3, 2 units to the left, up by 1. 2 pi over 3, 2 pi is 12 units across, so we're going to be 4 units. Shift left by 2, up by 1, we end up here. So we get this much narrower curve, and that is our new transformed function. Our characteristics are amplitude. We had a vertical stretch by negative 3. The negative doesn't affect the amplitude, but the 3 certainly does. So we have an amplitude of 3. Our period is 2 pi divided by our d coefficient. So in this case, our d was 3. So our period is going to be 2 pi over 3. So to complete one cycle, 1, 2, 3, 4 of these units, we already had known that 4 units across was 2 pi over 3. So that makes sense looking at our graph. Equation of the axis. Our equation of our axis from the graph looks like it's going through 1. Makes sense because we had a vertical shift up by 1. So it's going to be y equals 1. Phase shift. We did have a phase shift. We did have a horizontal translation, a horizontal shift. We went left by pi over 3. So our phase shift is left by pi over 3. Domain and range for all of these sine and cosine functions. Domain is all real numbers. Tan, remember it's not. But our range, we need our minimum and maximum values involved. So our minimum was negative 2. Our maximum is 4. Which makes sense because we're going 3 below 1 is negative 2. 3 above 1 was 4. So that all checks out. Look at one more example here using graphs. So our third example here, we have y equals 2 cosines. We're looking at a cosine function this time, of half theta minus pi over 12 minus 1. We notice our d value is not 1. We have a phase shift, so we need to make sure we're factoring. So we can rewrite this as y equals 2 cosine. We factor out the half. So if we take a half out of pi over 12 divided by a half, or pi over 12 times half, gives us pi over 6. And you can always double check by multiplying it back in. A half times negative pi over 6. Yes, that gives us negative pi over 12. So that's good. That lets us know that we did that correctly. We have a 2. Our a is 2. So we have a vertical stretch by a factor of 2. D is a half. We have a horizontal stretch also by a factor of 2. We have a phase shift right by pi over 6. And we have a shift down by 1. So we can look at our coordinates. This time we're doing it in terms of theta instead of x. That's okay, we're still doing it the same method. So we divide by our d value, or we can remember that we had a horizontal stretch by 2. We have a vertical stretch by 2. We multiply by our a value. So we're going to multiply all of our theta and y values by 2. For cosine, when theta equals 0, that's when we're at our maximum. And then every quarter of our period, we're changing. So we go down to the axis, down to our minimum, up to our axis, and finally, after a full cycle, back up to our maximum. We are going to multiply all of our values by 2 to get 0, 2, pi, 0, 2 pi, negative 2, 3 pi, 0, and 4 pi, 2. And remember, we are shifting. We're shifting right by pi over 6. We're shifting down by 1. So our original function, our original cosine, 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, 1. That is one cycle of our parent function, our y equals cosine of theta. Now our transformed function, so 0, 2, shift right by pi over 6. So that's pi is 6 of these units. We go over 1 unit, down 1 to here. Pi 0 over pi over 6, down 1. 2 pi negative 2 over pi over 6, down 1. Let's put a negative 3 on here. 3 pi 0 over pi over 6, down 1. 4 pi 2 over pi over 6. Sorry. 4 pi 2 over pi over 6, down 1. So we have a much more stretched out cycle. This is our function y equals 2 cos half theta minus pi over 12 minus 1. Amplitude. Our amplitude, our distance from our maximum to our axis is 2. Our period, which was always 2 pi over d. D in this case was a half, so 2 pi over a half. Same as 2 pi times 2 is going to be 4 pi. It takes us 4 pi to complete one cycle. Equation of our axis. Our axis of symmetry is y equals -1. Phase shift. Everything got shifted pi over 6 to the right. Domain, as always, x is an element of all real numbers. Range, y is an element of all real numbers such that our minimum of -3 less than or equal to y is less than or equal to our maximum of 1. So we don't need to always graph for these functions. We can do a lot of this just by looking at the equations now that we have a little more experience. So we'll look at a couple examples here. Y equals -4 sine of 2 times theta minus pi over 6. And we're going to be asked, what is our amplitude? What is our period? Vertical translation. Phase shift. And our range. So amplitude. Amplitude is always coming from this a value. So our amplitude is going to be 4. That a vertical stretch of 4 is going to stretch our amplitude out. Period is always coming from our d value, 2 pi over d. We have a d of 2, so we have a horizontal compression by a half. We're dividing our period by 2, and that means our period is going to be pi. Vertical translation, so shifting up and down, there's no value being added or subtracted, so we have no vertical shift. Phase shift is coming from our horizontal translation. We're going right by pi over 6. And our range, we want to look at our amplitude and our vertical translation. We have no vertical translation, so that means that our equation of the axis is going to be just y equals 0. It's not getting shifted up or down. And we're going 4 above and below that. So 4 below would be -4. 4 above would be +4. Let's try another example here. y equals a half cosine 2 over 3 theta plus pi over 4 minus a half. Amplitude, again, coming from our a value. So our amplitude is 1/2. Our period is 2 pi over d. So 2 pi divided by 2 over 3, or 2 pi times 3 over 2. 2's cancel out, and we get a period of 3 pi. Vertical translation, we're shifting down by a half. Phase shift, we're shifting left by pi over 4. And our range our minimum value, so our axis symmetry is going to be y equals negative a half. And we need to go half below that, which is negative 1. And half above that is going to be 0. So our range, we're stuck between negative 1 and 0. We can go the opposite way too. If we're told we have a sine function with an amplitude of 1, a period of 4 pi, a phase shift, pi over 2 to the left, vertical translation, none. Then we can combine this all. Remember our base function, or sorry, our general function is a times sine d to the x minus h plus c. So our amplitude is 1. So a is going to be 1 times sine. Period is 4 pi. So period's 2 pi over d. We can rearrange that, and d is 2 pi over our period, or 2 pi over 4 pi. Our pi's cancel out. 2 over 4 is just a half, so d has to be 1/2. Shifting left pi over 2, we get x plus pi over 2. And no vertical translation, so we're going to have no c, plus, it's just plus 0. C is 0. So we can rewrite this and it'll look a little nicer. Y equals sine half x plus pi over 2. And that would be our sine function that meets all this criteria. Look at a cosine example as well. Tell us we have a cosine function, amplitude of 4, period is pi over 2, phase shift none, vertical translation up 3. The general cosine function looks the exact same, just has a cosine instead of a sine. Amplitude of 4, a is 4. Our d from that rearranged equation is 2 pi over the period. Period is pi over 2, so 2 pi divided by pi over 2, that's the same as 2 pi times 2 over pi. Pi's cancel out. 2 times 2, you just get 4. So our d equals 4. No phase shift. So we just have an x. Our h is 0. And then we're shifting up by 3. So we add plus 3 on the end. So 4 cos 4x plus 3 is a cosine function, or the cosine function that meets all that criteria. So that's the end of this 5th lesson. Keep working hard. Keep letting me know if there's ever anything I can do that might make learning in this environment easier, or if you have any questions. But for now, you'll hear from me in the next lesson video that you watch or on the classroom. Have a good day and goodbye.